In this clip, we're going to get our hands dirty actually checking the health of our system memory and our storage drives. The problem with testing RAM is that you can't really do it accurately when the RAM is being used. But you can't do it at all if the computer isn't running. So you need to compromise by executing the test before the whole kernel actually loads. One good way to do that is to boot to a shell from grub. On this Ubuntu system, I can force the grub menu to appear by pressing the Shift key during boot and selecting Recovery Mode. I'll need to enable networking first because there's a package I'll need to download. And then drop to a root shell and install the package. It's called memtester. Before running the test itself, I'll run free to see exactly how much RAM is currently available. That'll show me how much RAM I can tell memtester to try to test. If I set this value too high, the test will fail. The 1 means that I want to cycle through the testing only once. You might want to put it through 5 or so cycles to be more thorough. This should only take a minute or two, but I'll skip through some of that time by pausing the video. When it's done, I can see I've got a clean bill of health, but any failures would be noted in the output. As a rather broad generalization, an error in this output would suggest that you might have a problem with at least one of your modules. To get a more precise view, you can physically remove all but one of your modules and run the test again, repeating until you've tested each module and you're sure which module is causing the trouble. Now let's move on to worrying about our storage drives. The weapon we'll use to fight that war is SMART, which stands for Self-Monitoring, Analysis, and Reporting Technology. SMART is a standard for discovering the potential for predictable hardware failures before the failure actually happens. The obvious benefit is that without advance warning, you'll be able to replace a dying drive before it actually goes down, taking your data with it. On Linux, you access SMART data using the smartctl tool that's part of the smartmon tools package. The first step is to quickly confirm what drives are actually connected to our machine. The only non-virtual drive here is my root partition mounted at dev/sda. Keep that in mind. I'll run smartctl with the -i option and point it to that drive to get some basic information. The most important detail here is that SMART support is both available and enabled. Not all storage devices are compatible with the SMART system. But it also identifies the device and tells us that it's a solid-state SATA drive with a capacity of 0.5 terabyte. smartctl-A will show us all the attributes available on this drive, along with the type of metric each attribute represents. This screen doesn't include any actual test results, it's just informational. You can access the results of previous tests run on a particular drive using -L and a reference to the particular test. Self-test and xerror are examples of such data, but devstat will be particularly interesting because it gives you some important insights into your device's history. That includes the number of times the device has been booted, how many hours it's run through its lifetime, and the number of write commands that have been executed, which can be very helpful if your solid-state device model has a history of failure after a certain number of writes. It'll also give you very detailed information about the temperature-related events to which the device has been exposed. This will be especially useful for rotating hard drives, which generate a lot of heat, but don't get along well with it. Let's run an actual test. The -T option lets us specify a short test in this case. The program returns a "be patient, we're working" message and tells us to come back in a couple of minutes. I'll pause the recording until after that's all happened. When that's done, I'll run smartctl-L self-test again. This time there's a new result, and it's good news. Similarly, xerror tells us about any errors generated by the latest test. There are none in this case. How can you best make use of these tools? Well, obviously, if you're ever worried that something might not be right, you should immediately run tests and guide your response by the results you get. But you could also incorporate regular testing into your normal operations. Just remember that these tests won't necessarily catch every problem, and both storage drives and RAM have been known to fail without any warning. Find this useful? Why not follow the link in the description and head over to view the complete course on Pluralsight. And of course, for even more technology goodness, don't forget to subscribe to this channel.